Hello, everybody. My name is Tony Miracker, and I'm the section chair in Toronto. We have a great meeting this evening. I'll advance to the next slide. And pizza was brought to you by TTC 2023. It's going to happen sometime in June. We're not sure exactly what the dates are and what we're going to be presenting. It'll either be a one-day or two-day event. So we're early in the stages of planning this. Just so that you know, two ways of getting questions to the presenters after each presentation, in-house or on the Zoom question box. Don't use the chat box because then we only have one less place to look. And tonight's meeting was brought to you or co-organized by Richard Grunberg, Peter Armstrong, and Roy Falkman, who is going to be the MC for this evening. So I hand it over to Roy.
All right, good evening, everyone. Welcome. The first presenter is going to be Jadu Farrow, and then Pamela Bloom, and then Brad Dixon. Jadu Farrow is a fashion and portrait photographer working for Sony for 12 years. Works both with Sony's marketing team and their digital imaging department, and with Sony Pro Support for the Alpha camera line. Welcome, Jadu, and thank you.
So hello, everyone. For all those that are here, again, as I was introduced, my name is Jadu, and I've been with Sony for about 12 years. This chat will be about the mirrorless cameras for video production. Now, about 5 years ago, I was asked to give this lecture, and I was against the title at the time. And I would have recommended, if it was in the Sony world, the FS5, the FS7, as being a grab-and-go system that you can go into the field. My reasoning behind that would have been the ND filters. It would have been the larger battery life. These are the things that we kind of look at when we want to do this type of production. But of course, Sony, wanting to elevate Alpha, which is the mirrorless brand for Sony, they wanted to do Hollywood productions and to see if they could actually get it done with mirrorless cameras at the time. So we're talking about, in this case, 2018. And these are the two case scenarios: the possession of Hannah Grace and Proud Mary. So this was one of the first productions that was actually done using the A7S Mark II camera. The whole idea here was, again, saving on cost, time, and the low light capabilities of this specific camera. Then Proud Mary was an actual, another production movie that came out, in which case they used the S2 again, the Sony A9, and this little small RXO camera, the RX0. Now, the issue at this time of using that S3 is that, yes, it was good for low light, but it still used contrast detection for autofocus. So all of your lenses, everything else that you needed to use to get the production going, didn't really match up with what the camera can do, other than it just being a really good low light camera. Next in line was the A7 III. Now you got oversampled video, which is great. But again, for what you wanted in terms of autofocusing system, it did not have autofocus tracking. So it was kind of a first come, first serve if you were shooting wide. Then you got the higher resolution. Now suddenly they did improve the autofocusing system. Now real-time tracking was a part of it. But now you're looking at a 61 megapixel sensor, 6K oversampling, but it was only really good in Super 35. So you weren't utilizing the full frame sensor readout. And then finally, the Alpha 9, incredible stack sensor design, but again, not designed for video. So these were the tools at that time. So if someone were to ask me, hey, could you use mirrorless cameras? I'd be like, yeah, I guess you can make it work, but it was never designed that way. And at that time, this was as good as it got, but the caveat is that this was for photographers. So not having real-time tracking, but what they called IAF. Even in movie mode, yes, it would track as long as you had one subject. If there was multiple people in the frame, it would pick the person that's closest to camera because there was no way to track individual people in the shot. So again, they made it work with the restrictions of the time. Since then, and again, we're just talking about 5 years, but since then, now Sony has a huge lineup of lenses and also cameras. And one of the biggest tricks that always happens is that from one generation to the next generation, I would put that there's about 10 years worth of technology that has been implemented from one camera to the next camera. So when somebody is even trying to save a little money and say, oh, I won't get the latest camera, I'll get the one just before that. Even for the price point difference, there is no comparison in terms, and that's what we're gonna kind of go over during the presentations. So Sony has brought out cinema lenses that have parfocal design and no focus breathing, but again, very costly lenses to use. And Sony was moving into the era of now trying to include video features in all lenses, not just these specific cinema lenses. So for the E mount or the APS-C mount, they also came out with the 1635. And then of course here, where you see the technology of how they design the lenses itself. So the XD linear motors of our lenses, this really pushed things like autofocus to video. And there's basically 3 things that that XD linear motor does. It's silent, it's fast, and it's accurate. If you pair that with a camera body that can actually marry those 2 things together, then now you're getting some performance, and that's what we're going to be looking at as well. The optics, again, taking the example of a 24-70 or a 70-200, everyone knows that at that 2.8 wide open aperture, you're slightly getting a softer image, especially if you enlarge, than if you were shooting at an f4 or 5.6 or an f8. However, with the new advancements and the new lenses, you're getting tack sharp imaging at 2.8, which is another step forward. And then of course the construction, it has to be made for all weathers, especially if you're doing filming outdoors. So going into the brand new 70-200, just because of that XD linear motor, now you're looking at autofocus speeds 4 times faster than the previous model. This is again where Sony is trying to look at our lenses and say, we're not designing these lenses just for photographers, in this case, sports photography, but we want them to be just as good for videography as well. Another big one, and this is where you start to notice that parfocal design, that it's not necessarily you're designing a parfocal lens, but that it has a parfocal effect. And in this case, because of the tracking of the camera being so good, especially with autofocus, now you can actually track your subject zooming or even do a focus pull or an aperture pull and keep that subject in sharp focus the entire time without having that I would say unsavory look of the camera trying to hunt for your focus. It stays locked on to that subject. And of course, designing all lenses to be lighter for, again, that purpose of using it in the field, not having gear that's going to weigh down, especially if you're trying to mount this on gimbals and things like that. So this is, again, what we were talking about before, the S2 versus the S3. So a couple of things that they've done, 12 megapixels on both, and both of them are low light kings. So why is the S3 so much better? Because now it's a backside illuminated sensor. So it's actually more sensitive in lower light situations than its predecessor. And you start looking through all of the other features. This is where Sony was literally trying to design a camera specific for videographers. And so even though I consider this camera to be a hybrid camera, good for photos, good for video, Sony was like, we are making a video-centric alpha camera, mirrorless camera. So entering into this, again, 4K 24, 30, 60, and 120 at full pixel readout. Sony was always shooting in 8-bit depth, now finally getting to 10-bit, color sampling 422, 15 stops dynamic range. This is from what was inherited from the previous version. This is where the advancement really, again, took a step forward. Before, your level of control for autofocus was very slim. Now, all of a sudden, they do want you to have real-time IAF in movies, but not necessarily only during daylight, but also in low-light situations. The other thing is the transition speeds and subject shift. This allows you the control over if you want the subject to be in focus and locked on. Do you want the autofocus to bounce to something that's closest to camera? And then also, in terms of the transition speed, do you want the focus to go from something in the foreground to your main subject? Do you want that to be quick, or do you want that to be slow, a cinematic pull? So here they kind of showcase that as well, where you see the focus jump from foreground to background. In this case, it's locked on that subject, even though something is passing in front of the subject. Here as well, again, just showcasing depth. Something can be coming directly to camera and maintain in focus with the autofocusing system. Walking along. Notice that when she moves her head to the side, it doesn't just automatically start looking for the background. It will stay locked on her, and this is because of the real-time tracking capabilities of the camera. Another thing is stabilization. So in the past, this was literally what you can get. The next slide kind of shows what our active mode is when it's on and when it's on standard. So again, nothing crazy, just someone just walking through the park, it's handheld. I would pair that with a gimbal, and now you've got a complete Steadicam look. This is another huge step, and it is to include all of the different video formats, especially with the all-eye. I don't know if you all are familiar with one of the Hobbit films where there was a chase, they jumped into barrels in the water, and the camera would cut from the cinema camera to a GoPro and then back. No matter what they could do, it didn't match up. And it kind of took you out of the moment to say, is that a GoPro camera they're using in this feature film? So part of this is they're assuming that depending on the production that you're doing, that you might have an FX9, you might have a Venice recording. How do you pair up that footage with something that might come out of the S3? And this is it right here. To be able to record in all-eye and then transfer that over and blend it with footage from other cameras, other manufacturers, so that it looks seamless as if it was all recorded with the same camera. So this, of course, is the cinema line, starting at the top with the Venice, the FX9, the FX6, and the FX3 and FX30 are the two new additions. So before, within Sony, you had the cinema line of cameras, its own department, and then you had the alpha line of cameras that is typically for photographers. There came a point where those two meshed, and that was the S3 with the FX3. These two are pretty much the exact same camera. So all the stuff that I just went over about the S3 is included here, difference being that this has an XLR mic adapter. If you were to purchase this camera and then want to add an XLR adapter, that's an additional $800, but in this case, it comes included with this camera. So we kind of talk to our customers and say, okay, if you are a hybrid shooter, you need the photography and you need the video, you probably will go after the S3. If it's video only, you might go to the FX3. I myself deal with a lot of wedding photographers that are wedding photographers / videographers. And for them, they actually won't go after this because they want to do all their video and use the viewfinder. They want to check the video footage using the viewfinder of the camera. So something like this, even though it's what I would recommend for them, they would say, no, I'm going to stick with this camera. And because of this crossover, this is where the cinema line of Sony has now kind of entered into the alpha. The FX30 is the newest that has recently come out, And again, this is a price point because this is now an APS-C size sensor. All of the other features remain the same, including the body style. It's the same as the FX3. Only difference is that sensor inside is now APS-C. So the price point has come down. Now, even though this, you can get it with an XLR mic, it's actually sold more popular without the mic. And again, it's that idea of trying to get that system as small as possible. And then of course, the Alpha 1 for the Alpha line is the most expensive. And again, it covers everything. This is the all-in-one. Sony kind of has the R system, which is for resolution, the S system, which is for sensitivity, the 9 system, which is the sports photographer, and the Alpha 1 encompasses all of those things. And the S system, which we kind of go towards the cinema line, this is now put into this camera as well, and it was the first that introduced 8K video recording. So again, with all the same codec, but now you're getting 8.6K that's downsampled. And then you're also getting 4K 120 and 4K 60 at full pixel readout with, again, 10-bit. This camera was announced 2 weeks ago. For all those who know, is the R5. This, for me, was a shock because this camera has always been a photographer's camera. We've always marketed that way. This is for landscape photographers, cityscape photographers, product photographers. So for them to make a shift to video and introduce new features in this that are video centric, it's something that Sony once again is trying to shift to make all of our cameras a split between photography and videography. So as we were talking about the autofocusing system and real-time tracking is primarily based around the eye and the face recognition. Now with this new camera, they've introduced subject recognition. And now it's not only looking at the eye, the face, but also bodies, joints, limbs, and it kind of showcases what that AI chip is doing. So to our processors that we have in the camera, they have added a specific processor that is the AI for autofocus recognition. And once again, just to showcase the difference between the R Series 5 and the 4 and all the advancements that have come out that are, again, specifically for video. There are certain cameras that Sony did not intend to be video centric. They wanted to kind of make every camera unique to its field. But now with the added benefit of everybody kind of looking for what they want specifically for their production, far are the days, as the first slides kind of showed, where even though each camera had its niche audience, they were all lacking something. And now it's very easily that you can take the S3 for a very specific use in video. You can take the R5 for another type of use, but all of these are great tools to get the result that you're looking for. And that is it. I tried to keep it short.
Thank you, Jadu.
Yes. Are there any questions?
Some cameras, they have like raw output. Which cable you can take?
So HDMI,
Okay.
and actually for all the cameras after the S3, so that was the S3, the Mark IV, the R5, the Alpha 1, they all take full HDMI connection.
Okay, and HDMI, it's enough for like 16-bit raw.
Absolutely.
Wow, it's
So
huge.
the
file.
Atmos Ninja.
Okay,
Absolutely.
thank you.
Anything else? Are we
No
good to go?
questions virtually.
All right. Well, thank you very much.
Thank you, Jadu. And as a token of our appreciation, certificate for you. Thank you so
very
much.
Thank you.
All right. And Pamela, I'll get your presentation up. All right, welcome, Pamela. Pamela's from Rotolight, and we'll talk about technological advances in LED lighting and how they are not only shaping the way lighting companies bring new tech into filmmaking, but they are making filmmakers excited about how lighting technology is helping advance storytelling to a new level.
Perfect. Thank you for having me here today. I love this industry. I've been a filmmaker for over 20 years, a photographer over 10. And as it's mirrorless camera and continuous lighting are just a perfect marriage. And as you know, photography and filmmaking are also coming together in a very interesting relationship, which is fantastic for someone like me who has been in both industries for so long. It's exciting to see even now lighting come along in a way where we can use the same stuff for both the photography realm and broadcast and the filmmaking realm. A little bit about Rhodolite. Rhodolite's been around for about 13, 14 years. We're in the UK. Everything is made and manufactured in the UK, which, by the way, really makes a huge difference. We hardly have any supply chain issues, which has been a huge plus for us lately. We're a small family-owned company. The founder, we call him Rod Sr., AKA the Mad Scientist. One day he comes from a music and a photography background, and he was like, the sun is round, our lighting should be round. And he came up with this concept of a smaller version of this light, and that's how Rhodolite started. Our line of products, we've got our Neo, we have our EOS, which I have right here. We have an Innova, which we don't have out right now because we have a new version coming out this next year that's going to be IP65 rated, RGBWW. So I'm excited for that to come out. And then we, of course, have our 1x1 and our 1x2 panels. And we just recently announced the Pro version of these two lights, which is pretty exciting. Made in Britain, UK, like I mentioned. And what's cool about this is we are made in the same facilities as the Ministry of Defense, Boeing Aerospace, Red Bull Formula One, and McLaren. And when I got to tour the facility, the detail to quality and innovation is phenomenal. I remember I went there and I was jet lagged, but watching these engineers get excited about doing something different than cars and military stuff, it was the most amazing thing to see. These engineers lighting up, being able to talk about lighting, and their commitment to excellence is something I've never seen before. One thing that we do is we do full testing on 100% of all our products. Every light that goes out the door is quality tested before it even leaves the facility. A couple of things I'm going to talk about. I'm going to talk about our continuous light that also strobes. I'll talk about our SmartSoft diffusion, our touchscreen display, our new apps that we have, and of course, all of our special effects and our gels that we have included. First off, LEDs can strobe. Yes, they can. They can strobe. And how this came about is LEDs have a constant current that goes through them. And when you think about traditional strobes, they have to ramp up. They have to power up in order to get that, which is why you have recycle time. Well, with LEDs, they were playing around and like, you know what? Think of it as like a box or a square. There's no ramp. It's just like that. So when our engineers are working on the LED strobe motion, they realize there's no recycle time. It just powers up. It just goes. Not only that, which opens the huge door for how things are flashing now. And you get that power and you get no recycle time. In fact, I was using Sony at Kando one year, and I was showing off the lack of recycle time. And I'm holding down the shutter and it's going super fast. The only thing that held it back was how fast your memory card was. So, and it was amazing. Of course, you're making these massive GIFs with the models going like this and then waiting for the camera to catch up, and then you load it on the camera and it was like a massive file. But the fact that that technology is there is absolutely amazing. And what we did is with all our lights being able to strobe, we had Elechrome built in. But then when we announced the new Pro line of our lights these last couple weeks, a lot of our users were like, well, I have all these old lights and you just announced this Pro. Within 48 hours, our engineers managed to make our lights flash forward compatible. Meaning, if you have one Pro light, and let's say you have Godox, it'll make all the existing Rotolights work with that Godox. So the fact that engineers are working with our customer base in such a speed like that is pretty amazing. I actually wanted to go back. I actually forgot to talk about, while at the facility, I wanted to talk about some of the quality engineering that is going on. All of our lights are in the injectable mold. So it's a very, very strong plastic that when something like this drops, it's not going to shatter. It's actually going to absorb that impact. And I'm saying that because it's important. If we're going to have really great technology in these kind of products, you want to protect that technology so it's durable. The panels on our lights are made with the same material that you'll find in the police riot gear. So I mean, these guys are heat resistant. They're not gonna shatter. They're not gonna break. They're gonna hold up, because we all know what it's like on set. I had lights come back from Ozark and I had footprints on the lights. And they still worked. I remember the warehouse didn't check it before we went to an event, and I opened it up and I was like, oh, well, this has been on set for 3 months in the Ozark. I even had leaves in there. It was kind of funny. The gaffers actually loved it when they came and looked at it. But the point I'm trying to make is, like, these are so robust. It's pretty amazing. The next thing I want to talk about is the one that everyone loves to see, is this Smart Soft diffusion. It's equivalent to a 216 diffusion. And what it is, it's liquid crystals. And in their natural state, you know, they're all over the place. And then as you run electric current through them, they come and they settle down, and then you have your diffusion. The challenge with that is keeping your color temperature consistent as you dim up and down. And that's actually was kind of an engineering feat. And that's one of the reasons why Rotolight came a bit late in the game when it came to panels, because they wanted to make sure as you dim down, you weren't losing that color temperature. And as you look at the light, when you dim, you can see the light adjust in there to make sure that color temperature is consistent. And what you're doing, you're basically controlling that spread from a 60-degree to 150-degree spread. But I love that the technology is finally there, and it's going to keep getting better. Some of the applications that we were able to see positives come out of is when, you know, during COVID, Grey's Anatomy is one of the very first shows that came back online, and when they had the set lit and everything was ready, it was locked and you couldn't touch it. So being able to have a light like this, where you can wirelessly control this spread, was a really key factor for them, because they wanted to be able to, if they needed to pull back the diffusion, pull back the spread, or vice versa. Again, here's our little Neo guy right here. This guy is so much fun. I would have liked you if where am I at? I'm only at 60%. Magnetic diffusion. We took the technology of those big Titans and we put it all in our smaller lights. So even the special effects, even the 2500 gels are all in here. All the customizations that I can do, which is, as a photography, this is a lot. But on set, I can go in and, you know, I was gapping for a lens, and this is the only light I used for our beauty shot. I just had this on a boom pole, moving this back and forth, and it was with the bounce next to it. But this was perfect. This is all I needed. I made my life easier. As you know, when you lighting, start with one and then move on and move up and go from there. Our Pro Series that we just announced, believe it or not, we were able to have 25% more power into our existing line of lights. Our batteries are all non-proprietary because we, you know, wanted to make sure that we're working with existing technology. Touchscreen display, I was just kind of showing all this. Our D mounts or gold mounts, depending on, my New York guys love their gold mounts. And we're just going to keep improving. We're going to keep improving the digital diffusion. The biggest thing is my communication with my filmmakers. The more you guys talk to us, the better our lights are going to be for you. The better, people like Brad, who dive so deep into lighting, which we love people like that in this world, because you make lighting better. You make lighting better for our filmmakers. You make lighting better for our photographers, and you make filmmaking a better place. And thanks to minds like that, our engineers can continue geeking out, continue pushing that envelope. We're the new guys, and we're so grateful for the established lighting in the world, because without them, we wouldn't be where we are at. But with our technology, we are going to make people look and be like, you know what, there's better stuff out there, and let's push that narrative, and let's make our life on set better, and let's make our editors happier and our colorists fantastic, because that's what we're here for. So thank you. Is there any questions?
Excellent. Thank you, Pamela. That was great.
Thanks. Any questions at all? Yes.
Do you like package them in field kits?
Yes, absolutely. Yeah, they come in all sorts of kits, rental kits, studio carts, yeah, you name it. Soft cases, hard cases, light cases, you name it. Yeah.
All right. And any questions online?
No, just to give everybody a heads up on the virtual side, Detroit section hijacked our meeting because we do a SMPTE shared, and we just hijacked it back, so we're at war. So anyway, there's no questions.
Okay.
A streaming fight. Brad Dixon. Brad is a retired senior lighting designer and technical instructor at CBC. Brad's presentation covers the interplay between LED lighting and the camera. He will focus on the relationship to the spectral expectations of the camera and how to meet these spectral needs with LED fixtures. Brad will also cover how the camera itself can be used as a guideline to evaluate and calibrate LED fixtures to provide an optimum color response in the camera. He will look at current lighting measurement methods and show their shortfalls for LED lighting. Brad will also discuss video walls and issues they have when seen on camera. Welcome, Brad.
Thank you very much for coming, and I'm going to do all that in 30 minutes, hopefully. So we'll work on that. There we go. Okay, I've been working with LEDs for a number of years, and being a lighting designer, I was talking about LEDs. What's wrong with tungsten? Nothing, as far as I'm concerned, right? It's another tool, and that's my whole key in all this. Anytime I've dealt with lighting, I've always looked at the interplay between that and the camera. So I've done a lot of studios, LEDs for a few decades, worked with a lot of different manufacturers. And my focus has always been, no matter what light source I work with, is how is the camera reacting to that? Now it's interesting, talk about misinformation to a certain extent. Everybody says, oh, these LEDs have so many Kelvin temperature and all. Great. Kelvin temperature actually applies to a light that's produced through heat. Every Kelvin temperature, it actually equates to a Celsius temperature. And when an LED manufacturer says their lights are so many degrees Kelvin, and I'm saying, great, but I can still touch it. It's not a Kelvin temperature, right? In fact, it's correlated to Kelvin temperature. The point of this is that it's inherently, even in a correlated color temperature, you have variations. Because essentially, if we look at the CIE chart, we can turn around and look at the fact that, all right, ideally they should sit on the black body radiated curve, to be exact. But they can have the same correlated color temperature given to them at either end, top or bottom of that curve. So in this case, for example, I've got a 3000 correlated color temperature. You start seeing it's in one end of the spectrum and the other end of the spectrum. So it might shift more to the magenta, more to the green, etc. But it still has the same numbers. So if you want to play the numbers game, that's fine, right? But for me, it doesn't work. Right, so let's start looking at the light sources itself. So look at spectral power distribution. And I know that even the measurements we have now, or how we even measure radiation, et cetera, and all that stuff is still in flux and question, all that stuff, and whether this applies to LEDs and all that sort of stuff is all in question. How LEDs produce light is all a whole different system. But that being said, using the current measurement systems, you start looking at, well, look at the top, that's our spectral power distribution, basically measures the wavelengths, the relative energy and the wavelengths that the light produces. There's our tungsten curve, and we start seeing a great deal of red. We start looking at what the LEDs start producing, and they're claiming to be the same. It's not the same. As a matter of fact, here's some examples. Again, let's use Kelvin that they throw around. Well, these 70 degrees, 2,700 degrees Kelvin, there's a spectral power distribution. Realize on the side over there is what true tungsten looks like, a true tungsten source being a true Kelvin temperature source. So again, mixing up numbers and terminology, et cetera, getting down to the real heart of the light is what I'm looking at. I mean, other methods are out there, right? CRI was out there. Again, Illumination Engineering Society developed CRIs for your eye, right? Oh, let's expand that further. Let's go to TM3018. Okay, again, CRI is a limited number of colors, so we expand that into 99 colors with TM3018. Okay. Again, how does that relate to the camera? We look at SSI. All right, that looks at the spectral power distribution of two different sources and says, well, how much of a difference is there? Well, it gives a number of that. Well, let's get something that relates to the camera. We have TLCI, Television Lighting Color Index. Okay, designed for a 3-chip prism camera, not for a single chip bare filter camera, right? Again, is it better than CRI? Yeah, right? Is it personally my ideal? No, it gives some information. It's good. I mean, it's a good thing, but the information I want to see is how is the camera reacting with this light itself. So color meters, I worked in film, I had a color meter. I work in video, gone. I don't use color. My camera is my color meter, right? There's a lot of information we can obtain about the light before it hits the sensor, which is fine. You should know all this sort of stuff. My whole thing is that how does the light deal, or how does the sensor deal with the light that's hitting it? Now, here's 2 examples. I had a manufacturer come in and show, oh, we've got this light, you can dial in the color temperature. Oh, okay, yeah, you can dial it in, whatever you want. Well, I said, okay, so I should be able to dial it in. As you see on the right there, we've got a chip chart lit at 3050 degrees Kelvin by a tungsten source. I should be able to dial your light in with my camera lined up on that, and it should be seamless. You can see on the left, it's not. This wasn't a prototype unit, this is a production model. I should be able to dial in, and we start seeing we're actually into, far saturated than we should be if we look at the vectorscope. So again, we can play the numbers game, or we can look at how is the camera actually seeing it. So having seen this gone around for some time, all these numbers and terminology going around, I co-created the HS scope with James Brooks of Jurassic Technologies. What we did is we basically took the vector scope, and which measures the electronic chroma signal of the camera, and we put it on a horizontal plane. So all the different vectors, all the different colors are there. So what we're seeing is the amplitude generated in a camera by the different wavelengths of the light. Again, we use a DSC chart, a SMPTE recognized chart, as our reference source. So all those chips are referenced on the HS scope. So we're measuring that. So what's the white reference line there? Okay, this is showing, for example, if you want to match a tungsten source on a Sony Venice, that's what it expects to see from your spectral output. It expects to see that amplitude in the different wavelengths and the different chips on the chart itself. You match that, and the camera says, okay, I matched. So we take a look at the top, and frame number 1 shows we've got a reference. That's our tungsten on the Sony Venice on the chip chart. Good, there's the HS scope. We've stored that as a reading. Frame 2, we've actually fired up the LED fixture. We set it to what it said was 3200, and we start seeing, no, it's deficient in the magenta, it's deficient here and there. This is the camera telling me, right? This is not, the camera's now my color meter. We look at the bottom, we adjust the various LEDs, in this case it was RGBA, until we get matched up on the bottom there with the amplitude that was generated at the top by the tungsten light. So my whole goal in this is always to create harmony between the different lights. Now, another little feature we can do, we can actually calibrate another camera to emulate another camera. So for example, I can have a Sony Venice and I can take the chroma signal, just flatten it out. And then I've stored a Arri Alexa response, preset response to 3200. I now lay that on top of the flattened out Sony Venice response, and now it's emulating just in the HS scope what the chroma response of an Arri Alexa is. And I can do that for any camera. As a matter of fact, I can do it for webcam, etc. So now I can take it in and said, no, we're not making a webcam into an Arri Alexa. We're just saying you now emulate the response of an Arri Alexa. So how does this look? All right, so here is our Sony Venice. We're lit the DSC chart with tungsten. We then set our reference line, okay? Again, we're just measuring the amplitude of the electronic signal there. And we're saying, right, that's our starting point. Fire up the other LED that's set at 3200, and we start then fine tuning, in this case, RGBA, the values of it, until we customize it to what this Sony needs. Now, the other thing too is that every camera is different. Everybody says, oh, they're all the same. It's like, no. If they're all the same, why are you buying a Sony and why are you buying an Arri? They all have their own individual looks. My whole thing with the light is I should be able to get the look that Arri intended. I don't want the light to start shifting for me. The other thing too is that I'm going to have multiple different lights on set. I want them to balance on the camera that I'm using, right? So I now calibrate it to the camera through the HS scope. Now, let's talk about differences. Now, if you're familiar with the vector scope, we start seeing on our left over here, the blue line is where a skin tone usually sits, right? In this particular case, we've got an Arri Alexa. The person's lit at 3200 degrees Kelvin by a tungsten source. Good. And we start seeing on the right, that is actually an LED that's set as 3200. We start seeing skin tone shift towards the red. I don't mind, you don't have to be exact and accurate. For creative reasons, you can change things, no problem. I don't have an issue if you as the creator says, this is a look I want, by all means, there's no rules, but what I don't want is a light to decide for me. I don't want to put it on your face and start saying, wait a second, you shifted to red, this one shifted here. What are we, dancing skin tones now? So my whole goal is I don't want to change the look of the Arri, right? I'm using the Arri specifically for its look. I don't want the lights to start dictating how this Arri is responding. I want that light, right, to maintain the look that Arri had. Okay, now a number of manufacturers say, oh, our lights don't shift in color when they dim. Okay, fine, good. Did you quantify that in any way? In this particular case, we happen to have a light, and if we look at the top vector scope, we start seeing, okay, there it is at full. As we drop down in intensity, we start seeing, wait a second, there was a shift in color temperature. Realize that LEDs at different voltages don't react the same way, right? So it's not just a matter of like, oh, okay, we just pull everything down, everything goes down equally. So manufacturers have to be aware of that. Now, here is an example of the chroma shifting as we start dimming. If you look at the vector scope on the top right, we'll start seeing at some point it just physically moves. There we go. Now, again, I don't have a problem with the manufacturer knowing that and telling me that. I know, okay, fine, at this level, I'll turn around and do that. I'd prefer a manufacturer actually works on that and corrects it, but at least if I know about it, don't make blatant statements, that it doesn't shift without quantifying it. Now, here's an example of a manufacturer who did adhere to quantifying it and tested it out. We start seeing on the right, on the waveform, we have luminance dropping. The chroma signal basically just goes to the center and we're not having a shift. And we'll fade it up. So it can be done, right? Again, I just want to keep harmony between the different lights. If I start dimming this down, this one up, and all of a sudden I got shifting in chroma, and everybody says, oh, we can put a LUT on it. Okay, I don't know a LUT that I can turn around and just have this side of my face lit and this side of my face lit, and they're both, inaccurate, and the LUT's going to just fix this side or this side. A LUT is global. going to do the whole thing. Whereas my whole thing is if I match them and they're harmonious to begin with, then to the camera that I'm using, right? Because each camera has its own chroma fingerprint. Okay, now let's use color meter. Okay, fine. We did our test and we sat back and said, all right, here is on the Sony Venice on the left over here is our 3200-degree tungsten source lighting up the DSC chart. There we go. Well, let's match that with our LED light. I'm going to take my color meter and I'm going to go numbers. Let's play the numbers game. Well, we look at number 2, frame 2. Well, I'm at 2970 CCT. That's pretty close, right? Well, we start looking at the HS scope, compare that to the original HS scope reading. Camera saying, no, you're not. So let's get closer. It's 31996 over there. That's really close, right? But you look at the chroma response and it's saying, no, my numbers are happy. My color meter says I'm happy, right? I just find the color meter is difficult to keep in focus, hard to shoot with. And so the bottom line is that the camera's saying, no, you're not. That's why, as I say, I work with the HS scope, or at least look at the electronic chroma signal as your guideline. All right, now, here's an interesting thing. TM30 has come out and it's like, oh, well, that's a whole new way to try to measure it. Well, as a matter of fact, we measured this light. We had an HMI on our left over here. We measured it with on the DSC chart, and there it is on the HS scope. So we said, okay, well, let's dial it in. Let's get this right for TM3018. Let's use this as our guideline. Well, on the right, we got very close with the HS scope to what the original was. Had we gone with the TM30, it said, oh no, your green is way, way, way off, out of bounds. But in this case, the Sony Venice said, no, that's what I need. So again, it's just, again, I not to disparage color meters, I've got an electronic color meter in the camera, and each camera is going to respond differently. All right. The other thing is that people say, oh, let's put all the different LEDs into the light. Well, is an RGBA better than an RGBW? Is it this and that? The benefit of the HS scope is you can start seeing, did those additional LEDs actually equate to a better response on the camera, right? And that's the easy way to turn around and tell you. So, well, okay, are you giving a closer look to this a tungsten reproduction by having all these different LEDs? Right? Well, you can tell right away on the HS scope if you can or you can't. Okay, now we put, not to disparage anybody, but we put gels in everything, in every LED, right? Oh, we know this. Okay, what did you quantify that to? So, for example, on the left, on the HS scope, we have a Roscoe 52 on a tungsten source. We actually measured it on the HS scope, and you start seeing there is the spectral amplitude that the Sony Venice generates to a Roscoe 52. On the right over there, we put an LED up and we dialed it into the Roscoe 52. We start seeing, no, you're not. You can see that it's deficient in some of the spectral output amplitude. And as a matter of fact, it's actually gone over far saturation that's acceptable for the camera. Again, I'm just hesitant towards playing the numbers game. Now, some manufacturers have got it pretty good, right? In this case, on their top is a Roscoe 26, and we start seeing the HS scope, and we look in the bottom, there's a Roscoe gel of CCT of 3200, and it's pretty close. Same with Roscoe 80. So this is part of the benefit of the HS scope. We're looking at the camera's chroma signal as your guide. At least at this point, you sit back and say, do they match? Right? Do they come close? And what gets me is everybody says, oh, I don't use scopes on set. Okay, you use a monitor. A monitor changed electronic signal into visual display. What's a scope? That's all it does, is change electronic signal into a visual display. The only difference is your monitor can be way out of whack, miscalibrated, et cetera, whereas a scope, at least as a general reference, is consistent. So how does my light look on an Arri Alexa, right? Well, this is the whole thing of using your chroma signal as a guideline. The white reference line is there in the HS scope. That's what the Arri Alexa says is tungsten. This is all the different amplitudes you need in the different relationship with regards to the chips there. That's what it has to generate. You start seeing this particular light is deficient in certain areas. right? So it's not, as far as the aerial access is, no, it's, and again, we just went to the presets. We didn't line up, we just went to the presets what the cameras had. Okay, LED walls, right? They're all fun. Thousands and thousands of LEDs. Okay, you have RGB and LED in LED walls, right? Now everybody says RGB. Okay, well, you look at the spectral power distribution, it's like, well, where's red? Where exactly are you putting your red, right? Where's exactly your green? Where's exactly your blue, right? Is it in line with the camera? So you now have these three limited sources that you're dealing with, and you've got to overlap them in such a way. And it's like, oh, you can light with LED volumes, right? And everybody says, well, having talked to Gaffer on Mandalorian, he had a long session with me because he wanted to find out more about the HS scope. It's like, no, sorry, there's deficiencies. And I'm also part of the American Society Cinematographers Lighting Committee, and we've talked about that there, and we're going to get into some solutions in a second or so about that. But again, as far as the image goes, that's fine, but as far as a lighting source, you simply will not have portion of the spectral output, the wavelengths that you need. I can't put them in if they're not there. I can take them away, but I can't put them in if they don't exist. Now, another thing, binning. You've got to make a lot of LEDs to get really good LEDs. So what happens is that they will bin. So what happens is a device will look at them and say, well, what is the quality? Where does it sit on the, as far as the CIE chromaticity chart? How close is it to the accurate color that we want, right? Well, you've got to make a number of them. So the further you get away, the cheaper the LED gets. The closer they get, the tighter the binning, the more expensive, right? So you've got an LED wall with thousands and thousands, you know, so you start sitting back, wait, it's like, you know, if you ever did wallpapering, you know that you had to get, you know, wallpaper rolls out of certain bolts and all that stuff would shift or look different. The same thing with LEDs, right? So actually, Tony, the guy of the Hong Kong Society, he utilized a HS scope to start looking at some video walls. And he was looking at the light output. He used a reference light of just basically going, okay, you're going to be 4000 K, so I'll turn around and put a CTB in front of a tungsten source, and we'll use that as a reference and start looking at the different, and you start seeing so many of them are off. Again, just lighting the chart, saying, trying to get there with the manufacturer setting, with different settings, with different things like that, see what he could turn around and get to, right? And he was just getting more and more issues with it. Okay, so let's get a white point. I've got a white point. Oh, I'm all good. Well, okay, yes, I got my RGB unit and I've got a white point, but I'm deficient in all the other, in all the other amplitudes of the colors. You start sitting back saying, it's like, wait a second, I'm not getting the color reproduction accurate. So let's adjust it, right? We couldn't get there. Well, red, which you're saying red, is that red matching with the camera's response, right? And so saying, no, we're a little bit shifted actually. So again, that red LED that you've got in there, right? How red is it in relation to the camera? Your greens, okay, it's actually responding. Again, this is a camera response. It's saying, you're not green, you're a bit more to the cyan, right? Again, individual cameras will respond differently. Blue, how is that looking? So again, this whole concept that we can have this RGB and make a white point, yeah, not an issue. Does that mean it's going to respond and give you the full reproduction of colors that you're expecting? No, it's going to be deficient. And we can see that in the camera's electronic chroma response. We see amplitudes that just totally depleted. Okay, so again, just with video walls, you start thinking of those thousands of LEDs. The higher end video walls, of course, they're going to looking at binning, but every LED, how tight is your binning is an issue, right? You want to get cheap, okay, that goes further away, and not every LED is created equal, so to speak, right? And the other thing too is you start dimming an LED, it doesn't respond exactly the same as the others, right? So as you start dimming a video wall, does it, again, we start going into the whole thing about chroma shift, we start seeing chroma shift in the video wall. So there's so many different elements that you're dealing with. Okay. And the other thing too is the virtual software is it actually putting out what you want it to be putting out accurately. All right. So again, even with video walls, I start looking at the chroma response, and I've dealt with video walls and projections for some time. Okay, so from the American Society of Cinematographers Lighting Committee, we pushed the fact that we don't like with video walls, so because you have deficiencies. So what are some of the answers? Well, Tim Kang, who I know very well, he runs the committee. Okay, what happens if we turn around and use the reference of the spectral output that we saw in the image, and we're able to transfer that into a light source? It's not just RGB. We expand RGB, warm white, cool white, etc., and any other thing we want to do. What happens when we map that image into that and use that as a light source? Right? So we're compensating for the deficiencies in the video screen. And that's what Tim has gone about doing in this case with Quasar Science. So they're actually mapping in the video image, but they're taking the reference from the original source and putting into a fuller spectrum LED fixture. So again, based on the zone system. Right? So again, we've taken the scene on the left over here, right? Spatial reflectance, we've got all that sort of stuff. Again, we've got the camera reference, putting it into a media server, mapping that into the LED light sources. But again, we're not just talking RGB LED light source, we're expanding on that. So the result is you're not getting just the limited RGB elements of it, right? We've got the reference source itself, and you're getting closer with an expanded RGB, warm white, cool white, etc. Fixture. We've actually expanded the spectral range, so we actually get a better quality spectral range that we expect, so a more natural look than lighting with the video wall. Now, Quasar Science is one company that's done that, and show you a new product. A person I know very well, Frieder Hoyam, is next up.
Hi there, I'm Frieder Hochheim, founder of Kino Lighting Systems, and we're here in sunny California. We're actually on a stage at Stargate Studios, and today we're experimenting with a lot of interactive lighting, volume lighting, and in particular, KinoFlow has come up with a new product called Mimic. This is a panel which is very much like a video display. So where a video wall, like behind me, is made up of a 3-color pixel, we've taken that concept, taken a 3-color pixel, turned it into a 5-color pixel. So in volume lighting, the desire has been there to use the volume as a light source. So very much like in nature, you've got a setting sun, you've got sunlight, whatever that scene is, it's actually lighting your subject. So the objective is, well, maybe we can use that image as a light source. Now, obviously, with only 3 emitters in a wall display, that has insufficient spectrum to properly illuminate the foreground subject. So what we've done now is created this panel, which can be fully synchronized with the volume, and will give you the full spectral quality of what it would be like as if you're shooting outside in the daytime, or respectively at night.
So I was speaking to Frieder the other day, and yesterday he would have been down at the Mandalorian Studios where they're experimenting and testing with the Mimic light. So again, Frieder's also on the panel, on the ASC panel that I'm on, and with Tim Kang, with these guys, and we've all been online is for anybody looking at who starts hearing, oh, you can just light with the video wall. No, there's options coming that are much better. Again, not my opinion, the camera's telling me that. So in an A/B comparison, I mean, personally, I've evaluated a number of different LED lights. I bought a number of them when I was at CBC, and I'd always look at my camera. So this is the reasons with HS. So if we look on the left, there's a tungsten light, right? and on the HS scope, and on the right is an LED. Forget about the numbers, forget about this and that. Right away you can say, oh, so it's going to be okay on camera. It's going to match. It's going to be giving me a good quality chroma response, right? My color is going to be accurate. My skin tone is going to be accurate. Costume is going to be accurate, etc. Right? And is it going to balance with the other light sources? Again, if you want a wider range, DSC makes a whole gamut of charts. You know, the entire spectrum, you've got that also. One other thing, solid state lighting, LED walls, etc. We're sending data everywhere. And something that SMPTE should get into, I think, is the fact that we have to have standards. We're not an office, we're not whatever, we're dealing with high amount volume of data, right? Transmitting stuff around. Well, we're also dealing with solid state lighting, we're dealing with LED walls. Well, guess what? We start having harmonics down the line, right? So our power, is that clean that we're using? Well, maybe we need some power conditioners kicking around, right? Oh, well, you know, I built my network at home, I've done this, we've done whatever. And the problem with IT people is that, yeah, you put in once and that's it. No, we're in and out all the time. So do not use these plastic little clips, RJ45s. Ethercon is so much better, right? We're a different industry, we're in and out all the time, right? Switches, no, you're not going down to the local electronics store and pick up a switch and picking whatever, because it might work for some data, but our industry, you know, it gets much broader. I mean, even in the case of lighting control, right? There are different networks. There's Ethernet, streaming AC, and ArtNet. You know, a variety of different networks, and some of them collide. You know, and again, you start saying there's a lot of data that we're running through that network. And all of a sudden, you're in production, and you go, oh, we'll just run everything on this 10 gig network, and we're all fine. It's like, you know, it's very easy to send a lot of data down that line, and it gets clogged. Are you doing unicast? Are you doing broadcast? All that sort of stuff, right? It's like, so something really to consider. Okay. All right. Hopefully that answers some questions. Thanks.
Thank you, Brad. Excellent. Any questions?
I have a question, but maybe it's nothing to do with what you are talking about, but
That's good.
something similar. Yeah.
Sure.
It's about LED and the camera as well.
Right.
I was shooting feature film a few months ago with Alexa LF.
Okay.
And we were in the background of the scene. It was big amateur LED screen. I don't think it's work. Oh, it's working.
Yeah. Okay. So yeah, so an LED screen in the background.
In the background, yeah.
Yeah.
And it was a lot of problem with flicker.
Yeah.
And so we find solution to change the shutter speed.
The frequency.
Yeah.
Yeah. And the camera.
But it works, but only if the camera is stable. When I move the camera, we have like zigzag movement, and we change our plan and we keep it stable because we don't have time to fix it. Do you recommend anything, please?
Well, okay. Yeah. First off, a lot of times you're dealing with a screen in the background that because a lot of them are dealing with pulse width modulation. So basically LEDs are on and off different syncs. So it's not syncing up with camera. It's the same way as cameras used to have clear scan even for, you know, monitors itself. So it would, you know, alleviate some of that, right? Part of it ends up being is that depending on the LED display, because it's not designed for camera, it's not designed, even volumes and all that stuff have to sync up with time code and all that stuff with the camera itself. So it's a bit of an inherent issue, right?
Yeah, and also sometimes we shoot in the street.
Yeah.
And we fix one LED but not others. And
oh, you mean the LEDs that you've got
in
firing
on the street?
Like,
yeah, like in the street LEDs, yeah.
Yeah.
Or coming from stores, or yeah. So
yeah.
how people deal with that usually?
Well, as I say, there used to be clear scan that used to be able to come in, turn around, and do that. But a lot of it, you know, a lot of it is going to be inherent with the frame rate we're using and the scan rate you're doing. The fact, you know, I mean, you can see it on the phone so many times. You see LEDs flashing, all that stuff. The scan is not exactly the same, right? Okay. So, I mean, one thing is to be aware of that. And you said, hey, if we're going to shoot here, here's a problem we might have, right?
Yeah.
Some of the cameras now have variable shutters.
Yeah.
And that allows you to then go to the 0.1, 0.3 that will then sync up with those types of difficult lighting situations.
Okay.
Yeah.
Thank you.
So again, clear scan, I'm going to Sony's and all that stuff back. I don't want to say, but yeah, you can basically, as he's saying, adjust your shutter, right, until you sync it up. But does that affect your other looks? Does that now start affecting your iris, that affecting all this sort of stuff, right? So it's, but the important thing is, saying to production, say, hey, maybe we should, like once you realize that, maybe we should just have a day of test shots, right? I know production doesn't like doing that or whatever, but it's like, it's either that or we get footage that's a waste of time, right? And if all of a sudden you want a particular look, right?
Oh, thank you so
But
much.
yeah, I mean, adjusting the shutter is one way to turn around doing it, right?
Okay. Thank you.
Hey, Brad, we got one from the outside world. And the
Okay.
question is, what light companies are showing accurately? And a follow-up question is, where are you getting your HS scopes?
Okay, well, first off, I've tested a lot of lights. I'm not going to say, because we're not supposed to do that at SMPTE here, as to which one is basically, I know which ones I would buy, right? But yeah, some manufacturers do it well. So I can't say, okay. HS scope, you can download it. It's part of a 4K scope software and also an 8K scope software from Drastic Technologies. You get all the other sort of scopes with it also. The benefit there was that James Brook of Drastic Technologies, I basically talked to him and I said, hey, there's a flaw. We need a link between how the camera responds, to easily display to people a visual display of what is good, which light is good, which light isn't, right? And this is what we basically derived. Any other questions? Okay. All right. Well,
Right.
thank you very much. Appreciate it.
Excellent. Thank you, Brad.
Oh, I got one.
Oh, you got one?
Yeah.
Wait, sounds like you're
who's-
fishing. I got one.
Whose responsibility would it be monitoring color fidelity of lights, cameras, or lighting?
Well, whose responsibility? Well, one thing I've been pushing is I think manufacturers should basically start displaying this in HS scope, so therefore you know what you're getting, right? The other thing too is that here's the thing. Now, it's not a matter that, I mean, some manufacturers, their scopes have worked on a wide, or their lights have worked on wide different cameras that we've tested. But now, Frieder Hoyam, his lights, he's calibrated. He and I know each other. We've had the same philosophy for a long time. He's actually calibrated stuff to the different cameras. So you can bring up a menu and say, go to this camera, right? He does different methodology, but that's something to be aware of, the fact that, well, is my light good on an ARRI? Well, no, let's cater it and let's store the look for the ARRI. Let's store the look for the Sony. Let's store this and that. My thing is that, it's sort of the horse before the cart. If end users are pushing and start saying, no, don't give me, this is what I was going about the numbers. Don't give me Kelvin, CCT, I know there's variations, spectrum, all this other information that's measuring the light, that's good, but it doesn't tell me what I need to know. How is this going to look on my camera? Is it going to be balanced to all the other lights? Because the other thing too is that there's a lot of good lights. I mean, road lights, they got all the different lights, it's all good. So if I'm using this one light, that's great. Now I bring in another light, right? It's like, okay, how is that going to be harmonious and balanced, right? The other thing too is that there's so many variables in cameras, right? I mean, Sony knows this, right?
I was going to say that even within that, you can have two of the exact same camera.
Yep.
And they will read color differently.
Yep.
And it's set up the exact same way.
Yeah. I mean, I don't know where Nirvana was, right? Everybody says, we got to adjust this to, it's like, well, I've never had two cameras match, as you're saying. This is why we used to calibrate and line up cameras. Two, I did award shows with like 4 follow spots. I'd have to calibrate each one of them, right? There's xenon. I'd have to filter out each one on camera and go from there. Tungsten? Oh yeah, tungsten's all solid. Really? A source 4 was always shifting ours to the green. Strand Cantata was much warmer than this, that. We had all the different things this way, right? Nienheimer was a different look, So HMI, really? Okay, it's older, it gets to the green. It's like, if everything was so balanced, how the heck did Roscoe keep in business with all of those correction gels that it had, right? We again calibrate it to match things on camera, right? So this isn't new. So you're going to say?
Yeah, more and more, you mentioned the chromatic response of the camera,
Yes.
where would that apply to when a camera has, it's running in custom mode where it's got its full colorimetry being processed versus a log mode or a raw mode?
Well, what I'm saying, well, even, okay, even in log, my whole thing is that if all of a sudden you're saying we got the full colorimetry of the camera, right? What happens when I go into log? If I balance everything, full colorimetry on the camera, what happens when I go to log mode, right? Everything that's balanced is adjusted the same in log, right? So if I had everything lit with tungsten, right, and it was all balanced and everything is equal, are you telling me when I go to log, it's going to shift the look of the different lights? No, it's going to sit back and say, okay, you're balanced, everything will move globally into it, right? Or like, move. That's my whole goal here. It's a matter of sitting back and let's make it all balanced and harmonious. That's the goal that I have, right? Then when you start doing things, going into log, it's the same, if you're outdoors and you've got, light coming from everywhere, it's all balanced spectrally, the camera's responding correctly. The issue is, what happens if I go in log? What happens if I have these, if I've got 5 different lights on me and they're responding 5 different ways, right? Then I go into log, it's not going to make it better. It's not going to correct it. It's just everything is going to be still inaccurate. Where if I start and they're all balanced on camera, even if I put a LUT on it, right? Everything will move proportionally, right? It's almost like as if everything was lit spectrally by a tungsten source, right? I mean, that's the way that I've operated anyways. It's just, and
Right.
again, I mean, to Sony's point is the fact that, no, it's like I get 2 Sony Venices. In our test, what we did, we always went with the presets, okay, what the manufacturer put in that would, because you can always go in the matrix of the Sony and adjust and do all this stuff, but no, this is what the manufacturer, it's the same with the ARRI. This is what ARRI gives us. I'm getting the ARRI look. I don't want my lights to start changing it.
In terms of your presets, when it comes to the Venice, is it a Rec 709 color preset or a DCI?
Yeah, well, we did tests in 709.
709, okay.
Yeah, but again, because if I can read the chroma signal, but and the other thing too is when people talk about 709 or 2020, what always gets me is like, okay, show me the white points in 2020, right? It shares them, right? 2020 is just the expanded, it's more saturated. It doesn't have separate, center points. It shares them with 709. So, yeah. So I mean, again, that's why I'm sitting back saying, okay, let's get it a balance.
Okay, thank you.
Right? Is that helpful? Did I answer it? Or?
You did, yes.
Oh, okay. Thanks.
Hey, Brad, does shooting in HDR expose deficiencies in lighting to a greater degree than SDR?
As far as the chroma response, no. I mean, because you're dealing with luminance value, right? Like we all our scope from HDR. Again, something I would say no and yes, right? I mean, it depends on, what's the situation, but generally as the norm is because you're dealing with a higher dynamic range, right? How does the camera respond? I guess, I'd turn it Sony rep. If all of a sudden, if I'm getting response up here, is that now bleeding in and affecting my chroma response, right? I can't say 100%, but looking at the HS scope, I'll sit back and say, let the camera tell me, right? But as I say, I mean, I love the fact you sat back and said, yeah, no 2 cameras are going to match the same. I love the manufacturer saying, being honest and saying, hey, this is what the reality is, right? It's not a deficiency in the camera, it's just the nature of it, right? Electronics shift, right? They get warm up, they do whatever, and the same thing with lights, right? They're gonna shift. So the big thing with, for example, if all of a sudden you shoot, let's say you're shooting Star Trek or doing whatever, you got certain color. The one benefit of the HS scope is I can store that look. I can then see later on when we come back and shoot it, has that color shifted? Because I can bring up my HS scope reference line and say, did it shift? I'll see right away if it has or it hasn't, right? Anyways.
I got a couple more there for you,
Okay.
Brad. What is the fall off of an LED?
Fall off in what way?
It just says, what is the fall off?
Fall
Of-
off as far as intensity? It depends on different LEDs, right? Because it, you know, what the optic of the LED is. So I'm not, you know, I'm assuming they're talking about luminance fall off.
Yeah.
So in other words, it's like, you know, inverse square law, et cetera, and all that sort of stuff. Whether that applies to LED, I just, you know, that would be in the specs of the LED as far as what the photometrics are. Because I mean, I've seen some LEDs that, you know, are equaling HMIs, so.
Okay, got another one here. What is the perceived wrapping qualities of the present LEDs?
Of the what qualities?
The wrapping qualities of a present LED.
Of the present LEDs?
Yeah.
Wrapping I'm just assuming that they're meaning the wraparound quality of it, like as being a soft light and that sort of stuff. Again, the problem with questions asked like that is like,
Yeah.
you know, I've got follow-up questions, so I'm just assuming from when hearing the wrapping
Oh.
qualities, wraparound qualities of it.
So Carlos just says fall off is compared to tungsten.
Fall off, I always think of fall off luminosity, like when you start looking at the inverse square law, right? Because sit back and say, well, it's the same as tungsten. It's like, well, no, tungsten produces light in a different way. It's a single, it's a, LED is like almost like like a cone that goes out, right? Whereas tungsten itself is, you're heating up that filament and it's radiating everywhere, right? So you start saying, well, even the basis of a foot candle, right? Does inverse square law apply to an LED? That's a big question, right? A lot of people are saying, no, it doesn't, because it produces light, essentially, you know, if it's chip on board, so flat panels or flat chip on board, it produces light totally different. It doesn't produce it all around, right? So again, I would sit back and say it depends on the LED itself as far as fall off goes, right? Again, I don't know if I'm answering the question totally because I'm not understanding exactly what's asked. You know, if regards to the fall off of luminance, you know, of the luminance of it, right?
So two more.
Okay.
How practical is LED binning to studio lighting standards?
How practical is it to studio lighting standards? Well, first off, there isn't any studio lighting standards in the sense that how is it important with regards to the camera, right? I would say it's extremely important because the variation is so strong, right? You can get lights, you know, from no name thing and they're, you know, way off as far as their, you know, the binning isn't tight at all and it's way off and it's cheap for a reason. The other thing too is they may put, you know, one good LED and they got X amount of, you know, further away binned, less tight LEDs, right? So sit back saying studio quality, it's like, it depends on the, you know, for the camera, right? So I would say that there's not a studio, oh, binning has to be this tight and all that sort of stuff. You know, part of the issue is that people have been throwing these numbers around and like I say, I've developed this and it's like, I'd like to sit back and say, you want to find out how tight it is or how good it is, start using the HS scope and start testing it, right? It's only as good as, you know, what the results are on camera, right? There's no, like, SMPTE doesn't have a standard for binning, right? I mean, it should be as tight as possible, right? It should be as close to the point as possible, right? But, you know, Frida Horium, you know, had a great line, said, yeah, I can make a great LED. It's going to cost X amount of dollars and you're not going to buy it, right? So there's a bit of a balancing act there.
And last question is, what does HS stand for?
Hue saturation. So that's where it actually does. It puts the hue, here's where the hue, how much saturation is that? I mean, technically it's amplitude, right? With regards to in the electronic signal itself, right? But it's the hue and saturation of that particular wavelength. You know, that all of those are referenced to the DSC chart, which is a chart recognized by SMPTE. There's the other thing too, is that DSC charts are calibrated to the response of the camera, right? Other charts are out there and it's like, no, sorry, I don't use them, right? This is consistent, right? The DSC chart. And that's why SMPTE sells it. That's why SMPTE recommends it. And that's why, you know, going to Sony, I mean, Sony uses the charts, right? Red, use charts, you know, broadcasters, that's the charts that we use everywhere as a reference. At least I know I've got a standard that I can sit back and say, okay, this is going to be consistent, right? with the charts because I know that they're calibrated. And the other thing too is the HS scope. I can sit back and say, oh, well, this light source that we've got here, well, I can put the camera up and I can get a reading of it. Now let's match to this light, right? And for this camera, and we can turn around and do that. So it's not just a matter of, oh, we've got to match it to tungsten. No, you can match it to your defined source that you want. The other thing too is that if you give your colorist and said, hey, you can tell them I'm deficient in this specific vector point, right? If we've got range, you may have to adjust. The other benefit too is shooting the DSE chart. You sit back, you can see it right on camera, right? But again, with the HS scope, I can tell you, yeah, okay, we're a bit deficient here, right? Here's where the problems are, right? And I showed this at BSC Expo, sometimes in London, all the colorists were coming up and said, yeah, we want this. Because my whole thing is that fix it in pre. The other thing too is that if you're going from a rental house, the rental house says, okay, what camera are you using? Oh, yeah, you're renting this? Okay, what settings are you using? They can now put in calibrated, right, values to it. Let's store this at all the setting using the HS scope. So now you go out and your lights are balanced, right? That's what I like to see. I mean, I did this all the time when I was using LEDs. I just basically go along with the camera and I would line it up. I did that with, xenons. I did it with, again, I never knew where Nirvana was. It's like I did it with every light source that worked on camera, right? I calibrated it so they're balanced. Again, it doesn't have to be. If you want to be creative, you want blue faces, you want whatever. I mean, people get this whole thing, oh, engineers, they're saying it has to be like this. I'm sorry, but I worked with video operators. They started in lighting, right? And it's like, yeah, what do you want to do? You're creative. Go for it. I'm not locking you in. These people who said, oh, I don't use scopes. Like I said, you use a monitor. It's a scope, right? It's just can be inaccurate. You got the scopes there. You sit back, just read it. It's just electronic signal into a visual display, right? Just gives you a little bit more detail, a little bit more information. People aren't handcuffing you creatively, right? That's not the goal of engineers. I mean, the gentleman from Sony knows that's not the goal. And even, Pamela from Rotolight, the goal of engineers is not to handcuff you. It's to say, how can we make this better for you, right? And this is part of what the HS scope is. How can we make things better for you? How can you easily see how well a light performs on camera? That was the whole point of it, right? Just make it simple, right?
We always find is that there's a balance between color accuracy and what's pleasing to the eye.
Yeah.
And more people would rather false color that's pleasing to the eye than actually get accurate color.
Yeah. Yeah. I mean, here's the technical thing, but that's a creative decision, right? And it's a matter of, a lot of times you'll see lighting, I put lights in, well, what's the justification of that light? What's this? It's like, because it looks good, right? And the best line when somebody says, well, how, you have light coming in and doesn't sort of look right. And the question is like, well, where's that light coming from and all this stuff? And I had the best line I heard was, it's the same place as the music comes from. Director was, what? Yeah, same place the music comes from. What are you talking about? Well, you have a scene, two people walking down the street, no dialogue, this and that. You get music in the background. Where'd the music come from? Right? It's like you put it in there just, because it looks good, right? It sounds good, does whatever. Some things it is just, so to your point of saying, yeah, creatively, I like this better. Sure, go for it. I'm not handcuffing you. But my whole thing is I don't want a light to decide that for me. I don't want light to say, oh, you're oversaturated, you're this and that and all that sort of stuff. And the problem is, when people say about lighting is good way or wrong way to light, it's like, yeah, I think there is a wrong way to light when you're not getting the look that you want and you don't know how to fix it, right? All of a sudden you get the look that you want. I don't care. You want blue faces, you want whatever the case is, go for it. I got what I want. My big thing is that I don't want these lights to come in, use this XYZ light and this light and ABC light and this and that. And you start putting it in, they're all over the place. They're deciding for you. And you played the numbers because they played the numbers game with you, right? Anyways, I'm just babbling on, so I won't do that. Okay.
All right. Thank you so much, Brad. And as a gesture of our appreciation, please accept our certificate.
Thanks, everybody. So we'll get our other presentation back up. So to the virtual guys again, we have two hiccups. This doing the hybrid virtual and in-house is, I think, a little bit more challenging for us than what we anticipated, but we'll get it right. And I'm going to go, keep going. Yes, that's perfect. Cool. All righty. So tonight we're going to get some of the recording because there'll be a gap where Detroit cut us off. But I think just as what we might do is we're going to get with SMPTE, we all share a same Zoom account. So I think we're going to divulge ourselves of that, and we'll get our own account so we don't have this mess up. So December's meeting, we are thinking that the organizers are still working on it, but there's a possibility we might be going out to Panasonic. So we'll let you know about that. January's meeting is going to be on multicast flow management, and we are looking at going to York Mills at the Rogers facility. February is going to be student focused. It'll be in the house here, and we're going to try and get, and if you know people, students that have been through and are already in the workforce, we'd love to talk to them to try and get an idea to the students that are current of what SMPTE can do and how it can help and things of that nature. And then in March, it's a standards update, 2110. Elections. We always think that we're in an election. So every year around this time, we're going to be asking for people that want to become involved in the board. So if you want to reach out to us, send us an email at simplytoronto@outlook.com and say, I'd like to be part of the board. But I'm also going to ask is, we have to have committees, and committees make up of past chairs and board members, but we need to get some people that are not involved in the SMPTE board level. So if any of you want to be on the panel so that we can hash out the names that we want to send forth to Home Office, then just let us know that you want to be participant in the committee of selecting what members that we want to, or what people we want to send to Home Office that will become part of the election process. Profusion is tomorrow and Thursday. We will have a booth there, and we would like you to drop by, say hello. We're 2106. We're beside Roscoe, and Red is next, and CSC is behind us, or we're behind them, depending on which way is north. Now, so we're going to do a couple of giveaways when we're there. Couple of things. One is, if you're not a SMPTE member, you want to become a SMPTE member, there is a discount code, 20% off. And then we're also going to have so if you become a friend with us at the show, we're going to give you a pair of Ross 3.0 socks. If you join up or extend or renew your membership, there's a prize pack giveaway. These guys are kind of, that's a charging cable. This one here is a little light that you can put on your laptop. That's for Zoom calls and that. Applied stocks. And so, yeah, if you drop by, that would be appreciated. Likewise here, this is SMPTE's they have their yearly progress report. It is going to be November the 15th from 11 to 3, and anybody can join. And that's the QR code. If you can get this all off the video when it comes out. Again, SMPTE TTC in 2023. if at the email, or if you want to reach out to any of us, if there are topics that you would like us to cover, people that you'd like us to bring in to say, we want to talk about, mobile trucks, if that's what you wanted to do and things of that nature, just let us know and we will, work around bringing people in. And a couple places that you can reach us. That's our website. Become a friend, that's the URL. And then Twitter and email. And then the video will be posted of what we have captured. So that's all I've got. So thank you very much. Thank you to our presenters for this evening. Sorry about the mishaps that we went to black a couple of times, but we will get that rectified and we should be good to go. So thank you for coming.